Thank you very much. My name is Kelvin Gregory, and I am passionate about bacteria and environmental biotechnology. And I'm going to be talking to you today about the power of bacteria and how they can help us in our human endeavors. So unfortunately, our most familiar perspective on bacteria is that of a detriment to ourselves through respiratory infections and bacterial diseases and tooth decay and, of course, foodborne illnesses. This is our perspective, but I would argue that more importantly, and a perspective that we are less familiar with, is that of how they can benefit us in our human endeavors. In particular, agriculture, biotechnology, producing antibiotics for us. They are necessary for food. They are necessary for waste disposal and waste cleanup. Environmental restoration, where they can clean up the messes that we've made. And as I'm going to show you here in a few moments, the power that bacteria have to actually generate electricity for us, as well as, in the not-so-distant future, the ability to sequester carbon dioxide out of the atmosphere and produce biofuels for us. So bacteria are very, very small. Bacteria are a micron in size, or about 4/100,000th of an inch. This is a picture of bacteria on the head of a needle. These cells come in a great diversity of shapes and sizes, and they can be quite beautiful and quite colorful, depending on the different species and how you view them. But most importantly, bacteria are extremely abundant. This single teaspoon of healthy agricultural soil is going to contain up to 1 billion bacteria and 100,000 different species within that teaspoon of soil. On a global scale, we're talking about an enormous amount of cells. 5 nonillion bacteria. That sounds like something your 10-year-old concocted. Is that even a number? Yes, it's a number. It's a 5 with 30 zeros after it. And that translates to 500 billion tons of mass of bacteria on the planet. That is about the same as the total mass of plants on planet Earth. And to put that into some perspective, all of the humans have a mass of about 100 million tons. So with this enormous abundance has come an enormous influence on our environment. The poster child for this is an organism known as Prochlorococcus. This organism is the most abundant one on Earth. It is estimated there's about 1 septillion, a 1 with 24 zeros after it, Prochlorococcus in the oceans. They are ubiquitous in the oceans. They are a marine phototroph that produces oxygen and sequesters carbon dioxide. Their impact is enormous. What they do in this production of oxygen is create about the same amount of oxygen that the Brazilian rainforest does. So about 20% of the oxygen on Earth is created by this one single organism. This is Manaus, a city of 2 million people. So the impact of Prochlorococcus has been huge. Now, they are very diverse. A single liter of seawater contains about 20,000 different species. Healthy human skin that we've spent time washing every day, hopefully, has about 1,000 different species of bacteria living on it. And they are colonizing your skin and providing a benefit in that they are helping protect your skin against invasion of detrimental organisms. And they are also participating in the renewal and regeneration of your skin by degrading dead skin cells. Now, I've said this word diversity several times, so I kind of want to put that into perspective. This is the real power of bacteria from a biotechnology perspective, is in this diversity. This is a graph. It is a phylogenetic tree of life, as we like to call it. And what it is a graph that represents the similarity of the DNA sequences in genes between different species of organisms. So what it really winds up being is, the way to interpret this is that a distance on this chart, the closer, that the shorter the lines are, the more similar two different organisms are. Here I've shown, highlighted animals and plants. These are the bacteria. You are more similar to the strawberry in your fruit salad than the bacteria are to each other. This is an incredible amount of diversity here. And this diversity in the genes is what gives rise to a great diversity in functions in the environment. So molecular biology, in just a few seconds here. Genes are contained in the DNA. These genes encode for proteins. These proteins are what are responsible for the enzymes that catalyze the tens of thousands of reactions that are taking place in cells. They provide cells with structure, and they also are regulating all of these thousands and thousands of processes occurring inside a cell. And these proteins are like components in a larger apparatus, in this case, a biological apparatus. Now, think about this in perspective of the electronics industry. Now, they've created an enormous, diverse, robust industry from about 15 different components, resistors, transistors, diodes, things like that. We've got a fairly robust industry here. We are aware of about 20 million different genes. We can reproduce these genes. We can reproduce the proteins from these genes. We have an enormous number of components or tools from which biotechnology can choose, 20 million. So I'm going to talk to you very briefly here about a biotechnology that I am particularly passionate about, and that is the ability of bacteria to generate electricity. So we have known for a very long time that the organic matter that is tied up in the sediments of oceans and in lakes and so forth contains an awful lot of energy. In fact, a cocktail napkin kind of calculation will show you that the sediment in the Gulf of Mexico, which is about 2% organic matter, contains enough energy to supply the entire United States with 1 year's worth of its electrical needs. So a lot of power tied up in that organic sediments. And the question is, how can we reach this energy? Bacteria have been utilizing this energy for tens of millions of years, degrading organic matter to generate the electricity that they need to reproduce themselves. And what they do is, in the degradation of this organic matter, they produce waste products. And these waste products accumulate at different levels within the sediment to different degrees. That accumulation of these waste products creates a voltage gradient, where we've got a fairly high potential at the interface between the water and the sediment at the bottom of the ocean, and a very low potential as you get deeper and deeper into the sediment. And all you have to do, just like a battery, is connect those two environments with a wire. So you put an electrode in the mud, in the sediment at the bottom of the ocean, you put another one overlying it in the oxidizing water, and electricity flows through that wire and generates electricity. Now, we do this in the laboratory. We have had cells doing this in these sediment batteries, a mud battery, for up to 5 years, producing stable electricity. We are able to power relatively small devices for very sustained amounts of time. And more recently, we've been miniaturizing this into micron-scale bacterial-powered batteries. These are batteries that you can only see with a microscope. And here's just a visual showing what this thing looks like in a flow-through system. Bacteria enter and specifically colonize one of the electrodes and oxidize organic matter, and electricity flows through this microbially powered fuel cell. When we look at the bacteria that have colonized these electrodes, we see very robust, healthy, growing communities that are thriving on these electrodes. And so the applications for this are, I think, quite important. Things like generating electricity in very remote places. How can you practically generate electricity at the bottom of the ocean? You need sensing devices that need power to communicate with the surface on a submerged pipeline that travels over 1,000 miles submerged. You need to know if that's corroding, for example. That's a good example. You can't practically change batteries at that depth in the ocean. There's applications in the mining industry, applications in human and healthcare industry, and hopefully what the take-home message here is that environmental biotechnology and bacteria have the power to change the world and improve and help our human endeavors, and we are only limited by our imaginations. Thank you very much.